Our objective is to make a half-wave rectifier circuit and to study its output waveform, right? So the components that we would need includes number one, the voltage source, right? And its value must be equal to 16.69 peak or 12 volts RMS, right? And the second component would be the silicon diode, and it has a number 1N4001. Then next comes the 10 kilo ohm resistor, and of course the first oscilloscope to measure the output wave. We have to take the following readings: the peak to peak, that would come from the oscilloscope. The frequency is predefined, it is 50 Hz, alright, and the RMS value, of the voltage would be taken from the multimeter, right? But multimeter when it is adjusted to AC waveform. Similarly, the average value is the DC voltage value, that too would also be taken from the multimeter, but multimeter set to DC. So let's begin with the practical. I'm using the software Multisim. So first of all, we will have to connect our voltage source, AC voltage source. We will go to the sources option, AC voltage source, and we will place it right here. Alright, so I have to take the value of 16.69 peak, so I'm going to write it here, 16.69 peak. Frequency is 50 Hz. Then we will place a diode 1N4001. 1N4001 is right here. The positive terminal of the AC source would be connected to the positive terminal of the diode, and the negative terminal of the diode would be connected to the resistor, 10 kilo ohm resistor. Right. Okay, it is convenient to rotate it right here. Now the value as it was defined, it should be 10 kilo ohm. Just connecting it to the negative terminal, and the other end of the resistor meets to the negative terminal of the AC source. We would connect the oscilloscope to we have to connect an oscilloscope across the resistor. Alright, and this oscilloscope would show us the peak to peak value. Alright, and we have to measure also the RMS and the average DC value. So for that we will have to place a multimeter. Let's connect the positive terminal to the positive side and the negative terminal to the negative side. Okay, make sure that the circuit is grounded. Now let's play the circuit. Alright, it was not grounded, sorry. Let's see what's the issue. Let's pick up a ground. All groups, ground. We were going to connect it right here. Now as our circuit is connected, it should work properly. Yes, it is working properly as the green lines running here indicates. Alright, so let's move forward and measure our peak to peak value, as it is getting out of our screen, so we are going to bring it down by decreasing the Y value. Alright, so now we are going to stop it and measure the peak to peak value, right? So What we have to do is now to calculate the vertical boxes, number of vertical boxes, right? So we have one whole box, two whole box, three whole box, and something above the third box. So we are going to take it as 3.2. Yes, it is going to be 3.2. All right, 5 volts for one box, and we are having 3.2 boxes. So the total volts would be 3.2 into 5, and we are going to get something which is equals to, let's check, going to get a value equals to 16 volts. So the peak to peak value is 16 volts, and the RMS value will be calculated from the multimeter. Turning on the circuit, the RMS value, make sure that the wave you have selected is the sine wave for calculating the RMS. So we are getting a value 6.165. We are going to write it right in the column 6.165, and then the turns come for the average value. The average value is the DC value, so make sure that the wave selected is a straight line, the DC line. So we are getting 5.067. We are going to insert these values in our table. 5.067. So this was the practical, and I hope that you will have understood it. Thank you.